So now the speaker is hitting the stage. Is the host of ROS Developers Open Class, our old friend Alberto Ezquero.
That rings some bell to me. He
Hello,
looks like
hello.
somebody similar.
Hello,
So wait,
Alberto.
Can you hear me?
wait. Then what is going to be talking, Alberto?
Yes. So Alberto is going to give a talk about an overview of the new features in ROS2 Iron Irwini.
Yeah, so the latest ROS2 distribution that has been recently released is called ROS2 Iron. And then Alberto is going to do a review of new features, interesting things. Of course, not everything, we don't have all the time, but some interesting points. So let's see what Alberto has to tell us. Alberto, are you ready?
Hello, hello.
Yes, we hear you.
Hello, everybody. All right.
Okay,
So
then go ahead.
Okay. Then hello, everybody, all the attendants to the ROS Developers Day. So, yeah, as Ricardo and Johan already said, today I'm going to be doing an overview about some of the new features introduced in the latest ROS2 release, which is Iron Irwini. So, my name is Alberto. Maybe some of you already know me from the open classes, which is a class that is free to attend for anybody. I am doing those ones on Tuesdays at 18 CEST. So in case that you didn't know about that, you can take note and come and meet me there, because we are usually doing classes like this one, explaining different topics related to robotics, ROS2, ROS, etc. And yeah, so today we are going to do an overview of some of the new features introduced in this ROS2 Iron release, which was actually released more or less a month ago at the end of May. Then, of course, there are many features from this new release. We are not going to be able to see all of them. I'm going to put the focus on some of the features that I found interesting, that might be interesting, and we can show some demos with them. In case that you are interested on checking the complete list of features, you have a link here in the notebook that you can click, and you're going to go to the official release page with details about all the different features that have been added in this latest release. All right? So let's go for it. Then let's start by launching a simulation, all right? So I would like to demonstrate these features with some practical demos, not just by explaining them and that's it, but by applying them to a simulation, let's say. So the first thing that I want you to do is to open a new shell. All right, you should already know how to do that from all the rosjects that you have opened today. Then let's open a new shell here, and we are going to copy here the first command that you have here in the section how to launch the simulation. Okay. Okay, we are having the typical live demo issue. So let me open again the rosject. Don't know what happened. Don't panic. Don't worry. Yeah, so I'm going to go back to where I was. I don't know. I was just disconnected for whatever reason. Let me go back to my rosject. There we go. All right. So as I was saying, let's start the simulation. So let's open a new shell, a new terminal here. And then let's paste this command here to the shell. This command here, it's launching a bash script, an SH script that is going to start a ROS2 simulation of an MP400 robot from Robotics, by the way. So after some seconds of processes being launched here, don't mind about all these error messages. They are not important. So a gazebo window should pop up like this one with the simulation. Okay, let's see. In some cases, the first time that you launch the simulation, it doesn't load completely, like the robot doesn't spawn, some strange timeouts happening there in Gazebo. So let's see if in this case it launches properly. If in the case that it doesn't, what I'm going to do is just relaunch the command and it's going to show properly. There it goes. Okay, so here we have the simulation. Yeah, this is a pretty basic environment, as you can see, with the robot here in the middle. This robot from Robotics in the middle. So this is the simulation that we are going to be using during the presentation in order to show and demonstrate the different features from ROS2 Iron. All right. Then an interesting thing that I would like to say is that the ROS2 Iron release is not long-term support, LTS. All right. So this is important, and you should take it into account in order to decide if you want to use Iron for your projects or not. Yeah. So Iron is not a long-term release, which means that it's going to be only supported till November 2024. Yeah. For instance, the previous release, which was Humble, it is a long-term support. Okay. So just something interesting that I think that you should know. Then let's get into the topic. So the very first feature that I want to review is the service introspection. Okay, so now with the ROS2 Iron release, it is possible to visualize service introspection. Yeah, which means that we can access to some metadata related to the services. Yeah, this might sound a little bit strange. So let's see a demonstration because this is going to make things much more clear. Okay, so here I have we have a command which is going to start a service. Okay, then let's copy this command here. Okay, from the shell, and again, I'm going to go back to my terminal, and without closing the first one, because here is where I have my simulation running, I'm going to open a second shell. Okay, you can rename this one if you want, for instance, to sim, to know that you have here the simulation running. There we go. Okay, and then here I'm going to run this command. Okay, so ROS to run service introspection, service introspection demo. Okay, so so far this doesn't tell me much, right? What I can see is that there is a service which is receiving an incoming request from the client, and then the client is printing here a value from the laser, right? So let me stop this for a moment, and let's have a look at the code, okay? So here we have this service introspection demo executable, which is the one that I am running right now, which is inside this service introspection package. So let's do one thing. Let's open the code editor by clicking here on the bottom right at the side of the shell. I'm going to do this myself right now. There we go. Because this is going to give us access to all the packages and everything that you have here in the rosject. So we are going to go to the ROS2 workspace, which is our workspace for ROS2. And here you're going to find a package which is called service introspection. Yeah. So let's go inside this package, and then inside the service introspection folder, you are going to find this Python script, service introspection demo.py, right? So let's have a quick look at this code and see what we are doing here. So first of all, we can see that we have a function here named check parameter, yeah, which basically it's looking for a parameter in a parameter list. It's checking the parameter type because it has to be a string, and then it checks that the value of the parameter is either of metadata or contents, yeah? So here we are expecting one parameter which should be set to of metadata or contents, right? We will see in a moment why, okay? Then we have here a class, which is this introspection client node, yeah? And we have another one down here, which is introspection service node, okay? Then what's going on here? Well, let's start by the service node. Here in the service, in the constructor, we can see that what we are doing is subscribing to the scan topic, so subscribing to the laser data, yeah? And in particular, here inside the laser callback, we can see that we are storing one value, one specific value from the laser, which is the one in the position 359, okay? Just so that you know, this value of the laser corresponds to the forward reading, yeah? So the simulation here, the robot, in this case, it's pointing in this direction towards this sphere. So the frontal reading, one of the frontal beams is this one, yeah? So we are capturing, we are saving into this laser forward variable the distance value of this laser beam, all right? Then, okay, then also we are creating a service here. The service is named get front laser, yeah? And then, of course, it has a callback, which is down here, where basically we are setting for the, as the response, the value of the laser forward, yeah? And then we return the response to the client, yeah? So we have a service which we can call in order to get the value of the frontal reading of the laser, okay? And then from the client side, which is up here, here we create the service client. Then from the client, we send, you can see here, an asynchronous call to this service, yeah? Then we capture the result and we print it, okay? Then we can see also here that we have a couple of additional functions on set parameter callback and on post set parameter callback. We have this for the client and we have this also for the service, yeah? And basically what this is doing is to check the parameter value, and if the value of the parameter is off, we are setting this service introspection state to off. If the value is metadata, we set it to metadata, and if the value is contents, we set it to contents. Yeah, this is the same for the client and for the server. Okay, then finally down here here we have a domain where we create the nodes, we create a multi-threaded executor where we add the nodes, etc. Okay, then what we are doing basically is to keep sending requests, right? We keep sending requests to our service, okay? Then what do I want to demonstrate here? Okay, so right now, this is a regular behavior service where I have a client, I have a server, and my client is sending requests to the server, which it's returning the value of the laser, right? Nothing strange here. Then if we check here the new feature, which says that we can get introspection data about the services. What does this mean? This means that if we have a service which is called, let's say, my service, then this introspection information is going to be published in a hidden topic named service event, okay? However, we have to bear in mind that this functionality by default is disabled, okay? So in order to enable it, we have to call this configure introspection. Okay, we have basically a couple of ways to activate this functionality. Yeah, because as you have seen, in order to activate this functionality, we have to do it through parameters. So one more time, let me launch the demo code here. And then I'm going to open another shell here to check a little bit what's going on here. Yeah. So here, right here, I can run a ROS2 topic list, which is going to show me absolutely nothing. Yeah. Why? Well, because ROS2 topic list doesn't show me hidden topics. Yeah. So if I want to visualize hidden topics, I need to add the include hidden topics flag like this. Okay. However, this is still not showing me the topic I am expecting, which is this service event. Yeah. Why is that? Well, that is because by default, this behavior, this functionality is disabled. So I have to activate it, right? Then one option to activate it is to directly set the parameter on runtime with a ROS2 param set. Yeah. So I can run this ROS2 param set introspection client configure introspection, and I set the parameter to metadata. Okay, so here you can run a ROS2 param list in order to see the parameters and how to access them. Yeah, where I have my parameters. Yeah, so here I have the introspection client and service parameters. Yeah, so in order to access them, I need to first introduce the namespace and then the name of the parameter. Yeah. So this is the command, then ROS2 param set, namespace, name of the parameter, and value for the parameter, right? So let's do this. Okay, set parameter successful. Then what if now I go to another shell? Here in my service, nothing has changed. Okay, so this keeps sending requests, returning responses, etc. Right? Then let me go to another shell, or even here, I can do it again. And do a ROS2 topic list again. And now we can see this topic here, yeah? Get from laser, which is the name of the service, and this service event, yeah? We know that this is a hidden topic because it starts with this underscore, right? So what if I subscribe to this topic? It's not getting. Let me copy it from here. Okay, so I can see that there is some information here. Yeah, we are getting some events, event type 3, event type 0, event type 3, event type 0. I get some information like the timestamp, GID, a global identification number, also request, response, okay? But so far here, what I have done is to activate the introspection only for the client, okay? Which works, but I think it's going to be much more sightful if we activate both of them, okay? Then for activating both of them, I'm going to do it in another way, which is directly on the startup of the services, yeah? So let me copy this command that I have down here. Yeah, ROS2 run service introspection demo, but then I add some ROS arguments, which is the parameter, client configure introspection, I set it to metadata, and the service configure introspection, I set it to metadata as well. Yeah. So now I am activating the metadata parameter for both the client and the server. Okay. So let me run this here. So the services are going to start interacting, and then again here I can subscribe to the service event topic, and here I'm going to start seeing all the events information. Yeah. So I'm going to see sequences of event type 0, event type 1, event type 2, and event type 3. Okay. I don't want to get too much in detail into all this, but basically event 0 and 1 means request sent and request received, and events 2 and event 3 are the response sent and response received. Yeah, so we can see the global identification number of the client, which can be useful for DDS features, all right? The timestamps, the sequence number, and we can even see the request and the response, yeah? But in order to visualize the request and the response, which are being used here, we need to activate not only the metadata, but also the contents, yeah? So we can also activate the content parameter. Yeah, I'm going to do it right now. So let me do it like this. Or actually, let me just ROS2 param set contents. There you go. And ROS2 param set introspection service configure introspection. What goes here? Let me say ROS2 param list. Okay. So ROS2 param set. There you go. Okay. So now, if we analyze this topic, we are going to be able to also see what are the requests and the response that are being sent. Okay, so we can see, for instance, for the events 0 and 1, which are the ones for the client, we can see that the request which is being sent is an empty message, right? And in events 2 and 3, which are the response sent and response received, we can see actually the response which is being sent to the client. Yeah. So this basically provides us some metadata, some information that in order to have a better idea of what's going on in this interaction between the service client and the service server. All right. So this is a very interesting new feature that has been added in the ROS2 Iron release. What else? Let's see another feature, which is the pre and post set parameter callback. So far until ROS2 Humble, we had one callback function that we could customize and modify when we change a parameter. Yeah. So whenever we change a parameter, for instance, with the ROS2 param set, okay, one callback function is triggered. Okay, and then that callback function allowed us to accept or discard the parameter change based on some criteria like the name of the parameter, the type of the parameter, etc. All right. So now in Iron, 2 additional callbacks have been added, which are the pre callback and the post callback. Yeah. So now we have this pre-set parameter callback, which allows you to modify the list of parameters. We have the set parameter callback, which cannot modify the list and should only accept or reject the parameter. Okay, this is the one that we had until now. Yeah, the middle one. And also in Iron, it has been added this post set parameter callback, which can make state changes based on parameters. All right. So let's have a look at this in the code. So we are going to run this code here for the demo. But before running it, we are going to have a look at the actual code so that we can have a better idea of what's going on here. Yeah. So again, let's have a look at this parameters demo package, which you can find it in the IDE. Parameters demo, and inside the parameters demo folder, you're going to find this parameters callback demo.py. Okay, this is the code that we are going to be running. So we can give it a quick look. Yeah, let me make this bigger. All right, so what do we have here? Okay, so we have this class, set parameters callback, where we are basically initializing a publisher to publish messages into the command bell, and we are also initializing a timer with its corresponding timer callback. Okay, then important, here we are declaring two parameters. One is named linear vel and the other one is named angular vel. Okay, they are pretty self-explanatory, right? And then here I am implementing the three callbacks that I was explaining right now. Okay, this one in the middle was the one that already existed in Humble, this one in the middle, but this pre and this post callbacks have been added in Iron. Okay, so in this preset parameter callback, what I am doing here is to get a parameter list. I am iterating over this parameter list, and then I check if there is one parameter which is named linear vel. Okay, and if so, this is interesting. If this condition is met, what I am doing is to change the another parameter value. Yeah. So if there is one parameter which is named linear vel in the parameter list, I'm going to change another parameter from the parameter list. In this case, I'm going to change the angular vel parameter and I'm going to set it to a value of 0.5. Okay. So I can change other parameters from the parameter list in this preset parameter callback. Yeah. Then after this callback, this one is executed. Yeah. Now in this one, I'm going to check all the parameters. Again, I'm iterating over all the parameters in the list, and then I can check some data if I want and accept the change, which means set the successful to true, or discard the change, which means setting the successful to true. Yeah. So if I set this value to true, the parameter, the update in the parameter value is going to be done. If I set this to false, the update in the parameter is going to be rejected. Okay. So this is what we can do here. We can basically accept or reject the parameter changes. Yeah, but we cannot change the values. This we are doing it here. Okay. And then finally, in the post set parameter callback, what I am doing is just to get the parameter value, the updated parameter value, and save it into an internal attribute of the class. Okay, which is this internal tracked param1 and internal tracked param2. Okay. Then, of course, we have to add the three callbacks. And then remember at the beginning that we were defining a timer as well. Yeah, we were defining the publisher for the command bell and a timer. This timer is going to be executed every 2 seconds. Okay, this is the period. Then what I am doing in this timer callback? Well, basically what I am doing is to set the linear velocity and angular velocities to the values of the parameters. Okay, and then once I have set the velocities to the values of the parameters, I publish this message in order to send these velocities to the robot. Okay? Yeah, so more or less, I think that you can get an idea of what's going on here in the code. Yeah? So now, yes, let's execute this demo. So let me open here the shell. And let me run the demo. Okay, there we go. So what now? Well, first of all, we can start by getting the parameter values. Yeah, so let me go to another shell and we can check the current value of the parameters. For instance, the linear vel here is 0 and the angular vel is 0, of course, yeah, because when I have created the parameters in my code, I have initialized them here to 0. Default value is going to be 0, yeah? Okay, then what I'm going to do now is to change the value of one of the parameters. Yeah, I'm going to do this through a service call. Okay, so I'm going to do this through a service call, ROS2 service call, set parameter callback, set parameter. Okay, and the parameter that I am changing, that I am updating in this case, it's the linear vel parameter. Yeah, so I am updating only the linear vel parameter, and I am setting this linear vel parameter to a value of 0.25. Okay? So what happens if I update this parameter? Well, that the robot should start receiving a linear velocity and therefore should start moving forward, right? So let's see what happens here. What we see is that actually the robot starts moving in circles. Yeah, interesting. Why? Well, this is exactly because of what I have just explained in the callbacks. Yeah. So if we come here and we check again the parameter values, let's check again the linear vel. It's going to be 0.25, right? It's the one that I have set here. But what about the angular? The angular value is now 0.5. Yeah. So what has happened here? What has happened is that by me updating the linear vel parameter, I am triggering this pre-set parameter callback function, right? Therefore, my callback function is detecting that there is a parameter named linear vel in the parameter list. So this condition is met, and then the callback, without me doing nothing from my side, the callback is automatically updating also the angular velocity parameter. Okay? So this is a very interesting feature as well, because this preset parameter callback and this post-set parameter callback, both of them have been introduced in Iron. Yeah, we didn't have access to these callbacks; they didn't exist in previous releases. So another interesting feature from Iron. Okay, let's keep moving. All right. Another interesting thing is the Matchet events. Okay, so Matchet events are events, as the name itself says, that are generated when any publisher and subscription establishes or drops a connection. Yeah. So whenever we establish a connection between one publisher and a topic, an event, a matched event is generated. And also, when I disconnect my publisher from a specific topic, a matched event is generated. Yeah. So basically here, there are two types of matched events, the publisher event and the subscription event. Yeah. The publisher event happens when it finds a subscription which matches the topic and has compatible QoS, of course, or a connected subscription is disconnected. And the subscription event is triggered when it finds a publisher which matches the topic or a connected publisher is disconnected. Okay? And with these events, okay, why I'm saying, okay, very well, Alberto. So when a publisher connects to a topic, there is an event generated. So what? Okay, so what? We can use these events in order to trigger certain behavior. Okay, so I'm going to start by running a regular demo, which is not using the simulation. Okay. In fact, I have stopped here the simulation. Okay, yeah, let me launch it again. I'm not going to use it now, but in a moment I will. So let me get it started here very well. Okay, so let's execute this first command here, yeah, which is going to execute a demo, a very simple demo, yeah. So we can see here many things that have been happening, yeah. So we can see here, create a new subscription. Okay, first subscription is connected. Create a new subscription. The changing number of connected subscription is 1 and current number of connected subscription is 2. Okay, so we can see like we are creating subscriptions and there is a node, which is this matched event detection node, which is detecting these events, these connections. Okay, then let's have a very quick look here at this code here. All right, so let's go to the demo node spy very quickly. You're going to find this one inside the demos folder, demo node spy, and demo node spy. And then I think it's events. There you go. Yeah. So demos, demo node spy, and events. And here you have this Matchet event detect.py. Okay. So let's open this one. Then let's try to explain as simple as possible what's going on inside this code. Okay. So as you can see here, we have three classes. Okay. We have this class, which is Matchet event detect node. We are going to check it in a moment. We have another class, which is multi-sup node, and another class, which is multi-poop node. Okay? Then let us start by analyzing this Matchet event detect node. So here, we start by creating a couple of private attributes. Okay? It's important that they are private. I know that they are private because they start with 2 underscores here, okay? This in Python means that these attributes are private, okay? Why am I saying this? I am saying this because it's going to be important later, okay? So I am creating a couple of private attributes here in order to count the publisher events and the subscription events, okay? To monitor them, basically. All right? Then I create a subscription event callback and a publisher event callback, okay? To register these Matchet events. All right? Then for each one of them, I have a callback function, of course, right? Then, for instance, this is the publisher event callback. Then here I am checking what's going on with the connections, yeah? For instance, so if we have a subscription connected to our publisher, yeah? So if there is any subscriber connected to our publisher, we are going to check if it's 0 or if it increases, yeah? This basically means that there is one publisher connected right now. Right? Because this is false. Okay? Then whenever I connect the first subscriber to my publisher, this is going to enter here, and we are going to register the first subscription connected. Okay? And then we are going to update the any subscription connected value to true. So for the next ones, we are going to enter this if here. Yeah? Then whenever we enter to this if here, it means that we have one subscription connected. Yeah? So the connections can drop to 0, which would mean that the last subscription, the only subscription is disconnected, or it can go up to 2, which would be this case. And then I can change the number from 1, which is the current, to 2. Yeah? And it's exactly the same logic in the subscriber event callback. Yeah? Both of them are initialized to false. So whenever we create the first connection, the code is going to enter here, and we are going to register that the first publisher is connected. From then, we update the value to true, so we are going to be entering this if statement. Yeah? And then we are going to have one connection, so the connections can either drop to 0, which means that the publisher has been disconnected, as you can see, or they can increase to 2, which means that the number of connections has gone from 1 to 2. Okay? So basically, we can register here all the connections and disconnections events. Yeah? We can register the first one. We can register if they increase here, and we can register if they go back to 0, so that the last connection has been disconnected. Okay? Yeah, so through these event callbacks, we can register all these events. Okay? Then what are we doing here in the multi-sub node and in the multi-pub node? Very simple. So what we are doing is just to generate subscribers and publishers. Yeah? In this case, it doesn't matter what we are doing inside. So for instance, here we are just creating a subscription to a topic, okay? And then we have this function to create one new subscriber, and we have this function, this method, to destroy one subscriber. Okay, so every time I call this method, I'm going to create a new subscription, which means that a new connection is going to be made. Yeah. And for the publisher, it's the same. Yeah, I have this class with the create one publisher method and the destroy one publisher method, right? Okay, so with all this, what am I doing down here in the main? Well, I am creating all the nodes and adding them to an executor. And then I start playing with creating and destroying publishers and subscribers in order to trigger all these events. Yeah, all these matched event callback. For instance, I start here by creating one subscriber. Yeah, so here we can see in the output, create an in-subscription, and then in the matched event detection node, we have the first subscription is connected. Okay, then I continue by create another subscription, subscription number 2. Yeah, here I create one subscription, here I create another subscription, right? So here we can see that create a new subscription, and then the changed number of connected subscription is 1, and current number is 2. So we have gone from 1 subscription to 2. Yeah. What else? Next, we destroy one subscription, and then we destroy the second subscription as well. Yeah. So we can see here, destroy a subscription. So the current number of connections has gone from, this should be 2, has gone to 1. Okay. And then we destroy another subscription, which means that the last subscription is disconnected. Okay. And then we do the same for the publisher. We start creating publishers and destroying them in order to trigger all these events. Okay. Okay. So this is very boring, right? All this is super boring. Alberto, stop telling me all these tales. So what? Okay. So what can I do with all this? Why should it matter to me? Because all this seems very, very, very cumbersome, right? Okay. Then for this, I have created a simplified example of a possible use case of this. Okay, a practical use case.
5 minutes, Alberto.
Okay, yeah, I'm going to show the example and then we can leave it here. Okay, then here I have created a practical application with the robot. Yeah. So let's have a look here at the Matchet events demo package that you can find also here in your ROS2 workspace. Here you have it, Matchet events demo. I'm going to open the folder, and here you have this matchet events.py script. Okay. So let's have a quick look at this. What are we doing here? Well, here I am using the same structure of the other code, but I am, instead of creating and destroying random publishers and subscribers, I am actually doing something which has an implication for the robot, right? So I have the same class matchet event detect node. This class is exactly the same, okay? Same class with the publisher matchet event callback and the sub matchet event callback, where I register any new connection or disconnection from the publishers and subscribers, okay? Then in the subscriber node, I am creating a subscription to the scan topic, to the laser topic, okay? And in the publisher node, I am creating a publisher for the command bell topic, okay? And furthermore, in my pub node, I have created a couple of additional functions. One is named move, and basically it sets some velocities for the robot to move in circles, as you can see, and a stop method, which basically sets the velocities to 0 in order to stop the robot. Okay, I have added these 2 additional methods here. Then what am I doing? Okay, so what I am doing here is to start by creating the laser subscriber. Okay, so that my robot is subscribed to the laser. Then after that, I create the command bell publisher. Yeah. Then here, for instance, I am checking that the connection has been made. Yeah. Oh, well, I am using this Matchet event detect node. Yeah. I am using this class and I am accessing these values, any subscription connected and any publisher connected. Yeah. Because with these values, I'm going to know if this is true, if this value is true, I know that the connection has been established, right? So I am checking this value, as you can see here. I am checking this value, and if it is true, if the connection has been made for the publisher, I call the move method. So I start moving the robot. Okay? So I make sure that the connection has been made, and then I start publishing velocities to the robot. Okay? But that's not everything, okay? Because I only want to move the robot as far as I have a node which is listening to the laser. Because while I am subscribed to the laser, I have information about the environment, okay? If for any reason my laser subscriber disconnects, I stop getting information from the laser, so I want to stop my robot. Do you see the scenario? Yeah. So I only want to move my robot as long as there is a node which is listening to the laser. Yeah, because this way I can get information about the obstacles around the robot. If this subscriber, if this laser subscriber, for whatever the reason, disconnects, then automatically I want to stop my robot to avoid crashing against anything. Okay. And this is what I am doing here. Yeah. What I am doing here is to check if I have the connection. If the connection of my subscriber is still there. If not, yeah. So if for whatever reason my subscriber dies and it stops being subscribed to the laser topic, it stops getting data from the laser topic, then I am going to say, hey, okay, so if this happens, I'm going to stop my robot. Yeah, so I call the stop method, and I also destroy the publisher, okay? And I am going to trigger this because right above here, after some seconds, after an sleep, I am forcing to destroy the laser subscriber. Okay? And we can very easily see this behavior. Right now, I'm going to execute this code here, and we are going to see the following. Let me put the robot here at one side. So I'm going to start this, and we are going to see that the robot is going to start moving. Yeah, the publisher is connected, so I start moving the robot. And then after around 20 seconds, I destroy the subscriber. And then because this connection is no longer there, I am saying, okay, then I want to stop my robot. There you go. Yeah. So I destroy the subscription. Laser subscription is disconnected. This disconnection is detected by my Matchet event detection node. So therefore, I trigger the behavior of the robot to stop because I no longer have data about my laser. Okay, so this is a practical, an example application, but there are many more. Okay, and yeah, so there are many more things here, many more demos that I had prepared, but yes, I guess that there's not enough time for everything.
You're right.
So yeah. Okay, so yeah, in any case, you have the rosject, so you can check them on your own and try them out. Okay.
Okay, very good. Thank you very much, Alberto. Excellent. Awesome overview and also awesome rosject that contains a lot of extra material for all the audience.
Yeah, thank you, Alberto. So now let's have some question. Attendees, please now go to the section Q&A tab and post your question. So we're going to pick the most voted one and to ask Alberto.
Yes. Okay. And
any question here?
Yeah, let's have a look at the sessions, and then in the meantime, let me start by asking my questions then here. Let me see.
I don't know if there are no questions because they didn't understand anything or.
Okay. Yes. Okay. Let's see. Well, they are starting to pop. You will see. Then my main question is, after you have reviewed there, so what are you still missing in ROS2 Iron? Something that you think, oh, so I would like that to have it solved in ROS2 Iron, but still don't.
Good
For example, in my case, is this symlink thing that doesn't actually work. I don't know in Iron if it is, because I haven't checked Iron, but in the previous ones, I always have problems with the symlink thing, and then you cannot trust it.
Yeah.
For example.
Yeah. I don't think so. At least for the release notes, I don't recall seeing nothing related to this symlink install feature. So I'm guessing it is still having some bugs and so on. And yeah, so maybe I didn't saw anything related to manipulation, neither in the Iron release notes. I know that for the latest releases they were working on improving the manipulation packages, things such as the Move It Setup Assistant. But I was trying that out in Humble, and it didn't quite work yet as it should. And I haven't seen anything for Iron related to all that. So I would say that keep improving manipulation libraries or porting everything that we have in ROS1, such as, for instance, the most known one is the Move It Setup Assistant to ROS2, and have it working properly.
Okay. Then I have also another question, which is the DDS default. Which one it is in Iron? Because it's been jumping from cyclone to fast, then to fast to jump cyclone.
I don't remember, but we can check it actually.
Okay. Yeah, you just by running on the screen, right?
No. Yeah. Oh, sorry, I am not sharing, right?
No.
I think I should. Okay, let me very quickly share my screen so that you can see what I do. Okay. Yeah, so basically what I did was to run the ROS2 doctor report command, okay, in order to get a report of the full system. And here we can see the middleware implementation, which is faster TPS. This is the default one.
Okay.
Faster
TPS is the default one. Okay, great. Good to know. Great. Then, okay, so we don't have more questions. We have one by Rodrigo, but I think that is not necessary because he's asking if the construct support Iron. We are running the construct.
Yeah. So yeah, this was I can show it in a minute if you allow me. So down here you're going to see it. You're going to see it here in the rosject. Okay, at the bottom I have shown that if you want, you can start playing with Iron in the construct. You can go to my rosject, create a new rosject, and then in the distribution you can choose ROS2 Iron. You can choose also Humble, Foxy, Galactic, many, but you have Iron, so you can start playing with Iron rosjects in the construct. Yeah.
Okay, then there are no more questions. Just one. Well, it's something. It's here on my mind. It's about it. You look familiar to me a little bit. I don't know. You look similar to this guy that saved our lives at the beginning of the conference from being killed by the Terminator.
Yeah. The one from the future.
No.
I don't
Doesn't
know.
ring a bell?
No.
Okay. Maybe you look kind of similar, but that's okay.
I guess.
Okay.
Okay. Thank you, Alberto.
You're welcome.